To start building the catcher game, we have the core stubs of the different objects that are going into the game, as well as the core of the game itself. So setup and draw have been stubbed out. We need to add some more into that. Clear background has been thrown in. So some of the core functions or methods that we're going to use in the project are included in the beginning files. So we can see that there is a catcher object, there's the drop object, and there's the timer object. We'll be integrating these into our project as we start developing it. So if you have questions about those individual classes, hopefully they will be covered and addressed as we build the project. So looking at the core of the project and getting it going, first we'll probably want to set up a basic size. Just going to start out with our simple ubiquitous 800 by 600. Now our draw function, eventually we'll clear background and figure out how we want to clear the background and work with that. But I can put in a basic background color if I'm so inclined. And just say background 128, so it's just the base middle gray. If I want to color, of course, I could specify my RGB color values in there and give the background a color, which we may do later. This intersect function that is included will be making more sense after we flesh out the classes and look at how we want to use that, so that we can figure out what happens when the objects run into each other. But like every other program, the best way to start is to break it into easy digestible pieces first, and then we add more to it. So the first object we want to look at is the catcher. So we want to build out the catcher object. Now if we look at the catcher constructor, we'll see that it's accepting a radius value for that object. Now one of the reasons that we will be using a radius value, because when we draw it in the beginning, we're just going to be drawing a circle. So with the catcher object, if I just say fill, and we'll just make our catcher white for now, and then we specify an ellipse value. Well, most of our objects we end up drawing at x and y coordinates. We can see we already will have those x and y values, so we will be working with those, and we'll figure out how to define them shortly. But our collision detection, or our intersect method that we're using, relies on knowing the radius of an object, because this is using circle-based collisions. We need to know the circle that encompasses a given object. But if I look at the normal definition that we often use when we do ellipse, is we use width and height. Well, in this case, they're both going to be the same because we're talking about a circle. But the width is not the radius, but it would be the diameter of the circle. So it's really the radius times 2 is what we're looking at there, because we need to know, in essence, what is the half width of the object. Subsequent projects, we will use rectangle-based collision, but the algorithm for figuring out when one rectangle has intersected another rectangle is a little bit more complex. That's why on this particular project, we're going to use circle-based collision detection methods. So there's a lot of kind of practices out in industry for figuring out how do you detect when one object collides with another in visual and game programming. And the easiest method to implement is circle-based collision. After that, we move into rectangle-based, and then we can start moving into map-based, so we're keeping track of the pixel versus transparent pixels of an object, so that it gets increasingly more complex. You can use triangle methods and different vertices. So there's a lot of complex ways that we can figure out, has one object intersected a different object. But the easiest way which is what we're going to use, requires us to know the radius of the object when we're using circle-based collision, which is where we're starting today. So this draws a circle on screen. We don't really know much else about the circle yet, but what we do want to do is to set our x and y value. We'll set it equal to the center of the stage, or our sketch. So set x and y equal to width divided by 2, height divided by 2. Now width and height in this instance, we see that they turn pink. And what they're doing is they're grabbing the global value that is set inside the main program's size declaration. So in the main program where it says size 800 by 600, that is where we set the width and height of our program. So once we declare that, every other time if we want to access that value, we just simply say width and height. And to put something in the middle, we just say width divided by 2, height divided by 2. Boom, it's now in the middle. Finally, we will set our property or value for this catcher object, and we will use the value we pass in, which is our catcher radius value. That is a parameter that gets passed in. So when we call the constructor and we will say catcher is equal to a new catcher, we'll pass in what we want the radius to actually be. The final thing that we're going to do is to update the x and y position based on where the mouse is in our program. So we can say x is equal to mouse x, y is equal to mouse y. And as we do this, we've now completed the catcher object. To implement this, what we can do is create an instance of it. So I can now say catcher is equal to a new catcher, and I can then just simply specify the size that I want it to be. So if I want the radius to be 16, that means my catcher will be a 32 pixel circle when we put it on screen. To see if that's happening, I can say catcher.update and catcher.display. So that will then call that every frame. So I'll save. Let me do a quick test run, and we can see that it is indeed working. Now we're not clearing the background, so this is almost more like a bad painting program than it is more of the game that we're looking for. So to clear the background, we could call the background command once more, or I could set a fill color of 128, 120, yeah, I'll do 128, 100. So it's transparent gray. Put in a rectangle from 0, 0 to width, height. So it starts in the top left corner, fills the screen, so 0, 0, WH. And now we need to clear background. Call that method inside of our draw function. And now when we update it, we can see it's working as expected. Moving on to the drop. The drop is where we get to see more interesting things happen. The drops, we will define their size right now. We will also define where we want them to show up. In the beginning, we're going to let our drops show up on screen. When we start progressing with the project, we're going to probably start them off screen so we don't have to see them, but it's good to see where they are so that we know they're actually showing up. So It's common if I've defined my properties for the object in this order, I then continue that process. So my x is going to be a random value, the width of the screen. That should keep most of them on stage. Otherwise, we may want to change the order of things just a little bit, and you'll see why in just a moment. The y will start them at 0. So that means they will show up on screen. At least half of them when they start at 0, the bottom half of it, because ellipses or circles draw from their center point. Then we will define our radius value. We'll just make them small, a radius of 8. So the drops will be a total size of a 16 pixel circle, while the catcher is a 32 pixel circle. And that seems to work okay for this. If when you build your project you make your objects bigger or smaller, it's all dependent on what you're trying to do. Probably don't go too much smaller. It gets hard to try to interact with things when they're much smaller than 16 pixels on screen. You could make them really small and make your project really brutal to play, but that's up to you. Now to define, oh, we already did that. Now speed y for this, we'll choose a random value, and the random value, I'm going to set the speed somewhere between 1 and 5. So with random, we can pass in a value and we'll get a result back 0 and to whatever the number we pass in. But we can also pass in a specific range if we want. In this case, I want my drops to be falling somewhere between 1 and 5 pixels per frame. Final thing will be to define the color we're going to use, and that will be a color value. And I'm going to initially set these at red. Now if we wanted to put in variety or anything else, we could put in some randomness like we've looked at previously. In this case, I'm going to start out with just a flat red as the base color. So this now populates all of the properties of each drop. The next thing is to figure out how these methods are going to work, and first we will start with update and display. We'll figure out what to do with cut and reset a little bit later, but I left those in so that we have our methods following the same naming convention, so that as we're developing the projects together, you don't go off on your own direction and then I'm looking at your code or you're trying to use mine and we've called things differently and then we're both confused as to what we're looking at. So update is about updating the position of the object. So we can do, in this case, I want to use the plus equals method, and we update the y position with our speed y. You could also say y is equal to y plus speed y if you like the more verbose way of doing it. So we first update the position, and then I'm going to check the bounds of it. With this, what I would like to do is to add in an asteroid wrap styling to this, so when I hit the bottom I go back to the top and then I can just keep repeating that following method. So to do that, whenever we're checking the boundaries, we need to then use a conditional. So if my y is greater than the height of my sketch, so that we now know it's bigger. Now there may be an issue with this code and we'll take a look at it in a little bit. Then we can say y is equal to 0. So with this, height is greater than, or when the y is greater than the height, but what we really want is when the height is greater than the height plus r, and then we don't want to reset it back to 0. Instead, we want to set it to negative r. And that allows, so the circle or the drop can completely leave the screen and then appear completely off the screen and fall back into the screen. That's going to give us a better visual experience. Display is going to be the same as what we've used before. We'll just fill with our color. and then draw our ellipse at x comma y comma r times 2, r times 2. And once we do that, we've now finished our first stage of working with the drop. And it's time to add in some drops. Now we can see that we will be using an array of drops, because with that array I can now have the number of drops that I want in my project, not just one. We could add in one just to make sure our drop class is working, but if we're confident in what we've done, we can go ahead and just make a whole army of drops that are going to fall on screen. So the first thing that I want to do is to declare how many I'm going to be using. And the reason that I already said int, now we just define it. The reason that we do it this way is we will be referencing this quantity or number of drops in a lot of places in the code. And if we hard coded in a number, then we would decide, oh, I want to go from 10 drops to 20 drops or 30 drops. Maybe your game has a level feature built into it, so each time you win and play again, it increases the difficulty. So you need to change how many of those drops are. Well, if that's based on just a value, it's really easy to do. But if it's hard coded in, that becomes much more challenging. So with this, I am going to, we'll just start out at 100 drops here. Nice, friendly, easy number. The next thing that we want to do is to define out our array of drops. Now, if using the word drop and drops, where it's just differentiation through plural, is difficult for you and you need to rename things so it's more separate, so you can see it in your code, you're welcome to do that. But the standard convention is when you have an array of objects, you use that plural version of your object type, so then you know just by looking at the code what is contained in it. So this will be a new drop, and now I use that array value that I specified. So drops is an array, so we use new to say I'm instantiating this array, what kind of objects will be in that array, and how many objects exist in it. So processing requires you, when you define an array, it wants to know how many objects are in that array, so how many spots to reserve in our stadium. It wants to know, if we go back to that stadium analogy, how many seats exist in that stadium. It needs to know that so it can reserve enough space in memory for that. The next item is to define out and populate that array. So you'll see how we are using that value of numDrops regularly, and we'll use it quite a few times. And then we grab each spot in the array, so drops I in square brackets is equal to a new drop. And because drop doesn't have any parameters that are passed into its constructor, we just have empty parentheses. The catcher class is expecting a number as part of its constructor, so it needs to have a value provided. The drops do not, they take care of themselves. So this now populates the drops. To see our objects appear on screen, we need to call their respective update and display. So each drop has an update and display method, so we need to call that. To do that, we need to cycle through our array of drops to do it. So for this, I will use a for loop, and it's going to be the same structure as what we just saw up in setup. And then we can, and I always close out, put the closing curly brace for my loops when I use them, and then we'll go back and populate it with the content. That keeps me from accidentally forgetting to put in a closing curly, which will then break our code. And I have this little extra equal sign in there that I put in when I was busy talking and typing at the same time. So now I can cycle through all my drops, telling each drop to update, each drop to display, and if we run this, we'll see all the drops fall down the screen. So what we have every time this runs, all the drops start falling simultaneously. Now we'll see some are faster, some are slower. You can follow a track a drop when it hits the bottom. You'll see how it's wrapping immediately back to the top. It's falling in a single column. It's possible that we could modify that to make it so that the drops appear more random, so every time they wrap they go to a new X position, so it doesn't appear to be the same drop, to increase the visual randomness or complexity of what's happening in our program. Now that we have the drops falling on screen, we have the catcher moving around based on the mouse positioning. What we need to do is figure out how to work with the drops when they are catching each other and make something happen with that. So if we want to make the drops disappear, we need to find out when they're hitting each other. And the way that we can do that is while we are going through the drops, we can tell a drop if it's been caught, to do something. And this is where we can figure out what we want to have happen. So we could tell a drop to sing and dance, we could tell it to go somewhere else, we could tell it to flip off, we could do whatever we want, but what's going to work better is just to take the drop and give ourselves a visual indicator that something happened. And the easiest way that we can do that is we can say speed y is going to be equal to 0. So when a drop is caught, then we can kill it so it no longer moves. That's a really easy way to stop the drop from doing anything. So in the game, we can update and display the drops. We also want to check for collisions. So some things I'm putting in comments, other things I'm not putting in comments, but when it's something new and breaking it out from what we've done previously, then I'm putting in comments to help us figure out what's going on. So what happens with the intersect function is the intersect function, we pass into it whatever drop we're checking and the catcher. So we pass into it as two values, and then we calculate the distance between the centers of the objects. And then we compare that distance and find out if that distance is less than the sum of the two radii of the objects, the radius of the catcher and the radius of the drop, then this method will return back a true statement to us. Otherwise, it returns a false value. So some functions, like clear background, return nothing, so they start out with void. Intersect is going to return a Boolean value. So this is where we get to say if intersect, and we're going to say of what, the catcher, and then the individual drop we're looking at, drops I, so if that intersect returns a true value, so if that is true, not ter, but true, so if intersect is true, then we want to do something. So curly brace, return twice, close curly brace. And now this is where we do something. And this is where I can now tell that particular drop that I just intersected, I'm going to call its caught method. With it running, we can see as I intersect the drops. Now sometimes it's a little bit hard to see with so many drops on screen, but you can see how when they touch me, when they touch the catcher, they stop moving. So I've nearly caught them all. There we go. Looks like they're all frozen on screen. So perhaps freezing them on screen isn't necessarily the best thing in that location, but what we could do when they are caught, kill their speed, and then set their y value equal to 0. By setting the y value equal to 0 in the individual drop, it's going to locate that drop. You'll see how they start lining up on the top of the screen. I could make them disappear somewhere off screen, but then I wouldn't know if I was successful in catching that drop. Is it actually working? So it's sometimes better right now during development to have the objects appear on screen when we're catching them versus having them completely disappear from the screen. Eventually, when we program the game, we won't set them at 0, but we will put them at a negative value so they're off screen so we don't see them. So it looks like we had a more definitive action occur. Working with the timer element inside of processing, it's a way that we can access the internal clock in the computer, and it gives us a value based in milliseconds. So when we use the actual timer object, we're going to be accessing a certain value. The value that we access is how many milliseconds have passed since the program started running. So we don't have to necessarily know, it's like, okay, well, what time is it now and how does that factor in to reset something to 0? We just need to know, okay, once the program starts running, it starts a stopwatch and it measures that in milliseconds or thousandths of a second. And then we can then question and say, yeah, well, what is the current time now? And when we do that, he'll say, well, okay, now it's this many milliseconds. Then we can ask again, hey, what's the current time now? And it'll tell us, well, what's the new current milliseconds? And all we have to do is some simple comparison between what is our current time versus what time did we start. Do a little simple subtraction, and that tells us how much time has passed. So it's a fairly straightforward process, but the syntax for it is never that pretty when we look at it. Now, the way that we're going to construct our timer. Now, technically, we could have all of this timer functionality embedded directly into our main program, but it does make sense to separate it out because down the road, we'll be adding this same functionality to future projects of having a countdown timer or any other type of in-game timer to control how things operate. And if it's already in a separate class, it's really easy just to take that class, copy it over to a new project folder, and you can start working with it right away. So you don't have to retype it. You can just recycle it and reuse it. And that is one of the advantages of doing class-based programming, is once you write a class, theoretically, you should hopefully be able to reuse that class in near or complete entirety in a future project. So when we create a timer, what we're going to do is we're going to pass into it a value, and it will be the interval of how we want to measure time. Like, do we want to measure it in seconds, half seconds, 10-second intervals, whatever we want to pass it in as. Because we may want to be measuring on a half-second interval, because if something is happening every second, that might be too far apart or take too long. So instead, we want to set our interval for this timer. And by having the timer in a class, we can make different instances of the timer. So we could have a grenade timer, we can have a countdown timer, we can have a health timer, a shield timer, all of these ways that we could integrate it. Each one could have a different time interval that it's looking for. So when we create a new instance of our timer object, we pass into it a value of how long interval do we want this timer to be clicking on. Is it a second timer, half second, 2 second, something. Now when we tell the timer to start, we're going to tell it that we want our start time property as part of this timer to be equal to the current millisecond value of how long this program's been running. So when we use the command millis, it grabs whatever the current millisecond value is since the program started running. Now, currently where it says return false, I'm going to get rid of that. I had to just put that in there for now because otherwise if it was left like this, none of our programs would have run all morning and I would have had to go comment the entire function out. So we'll get rid of that. Now we'll put it back in because anytime a function or method returns a value, in this case it's returning a Boolean value, a true false. Anytime it returns something, we have to somewhere in that function say return and then something of that type. So just going back to the game, Boolean intersect means intersect is returning a true or false value. So when I call intersect here, it's going to return a value that's either true or false. Where display doesn't return anything, so no big deal. So if I go look at the drop display, it's a void, so it's not giving us anything. It just does something. So some functions give us something, other functions do something. And the functions that give us something, that means they're returning a value. Intersect returns a Boolean. The timer complete is going to return a value as well. So the time that we'll be looking at so if I say my elapsed time is equal to the current time in milliseconds minus the start time, milliseconds, that's going to return a value. So if the program has been running for, let's say, 2,000 milliseconds, and I started at 1,000 milliseconds, then my elapsed time is going to be 1. Now, if my elapsed, oh, not elapsed, I wanted to say elapsed time. So if my elapsed time is greater than the interval that I've set up my timer to run, turn twice, close curly, up arrow once, and I forgot a P up there on elapsed. Now then, what I will say is return true. So if my elapsed time is greater than the interval, I'm going to return true, else curly, return twice, close curly, up arrow, return false. So the way that this will work is our main program is going to ask the timer, are you done yet? And every tick of the draw loop, so every time, 60 times per second we go through the draw loop, it's going to ask that question, hey, are you done yet? Hey, are you done yet? Hey, are you done yet? And eventually, my elapsed time will be larger than the interval I've set up, 1 second, 2 second, whatever it is. And once that's the case, it returns true. So we can make our timer able to work through and do this by asking the timer, are you done yet? In the main program, we're going to now add that timer object in. So I can say timer. And for this, the timer that we're going to work with here is we're going to be using this timer as a way to control our drops so that when we run the program, let me just comment that out and just show, when we run, we don't want all the drops to start falling right away. Instead, what we're going to try and do is modify the program a little bit so that first one drop falls, and then a second, then a third. So they sequentially will fall based on a time value that we pass to that timer. So that time value, so this will be my drop timer. And I'm naming it versus just calling it generic timer because as we develop the program, we may have other timers that we use. We may use a countdown timer, so we may flash numbers on screen, 3, 2, 1, go. Or we may say that the game is going to run for 30 seconds, and you have 30 seconds to play, and then the timer runs out. And then it's what was the best score you could accumulate during that window of time. So there's, depending on how you structure your project, is going to determine how you will further integrate timers into it. But right now we want to just use the one to control how the drops are going to be falling down on screen. So we'll call this one our drop timer. I'm going to add a few more variables that we're going to need to manage this. One will be our drop interval. And the final will be active drops. Now, active drops is how many drops are currently active and falling down the screen. So that's how we will be determining how do we add one to that sequence of drops that we are working with when we're trying to see them happen and show up and move down the screen. So to finish defining these new values inside of our setup, we'll set our active drops at 0. So we'll start out the game. There won't be any active drops, and then every click of the timer will increase active drops. We'll set our time interval equal to 100. Oh, sorry, drop interval. My bad. The timer interval for the drops to come down is called drop interval, and we'll set that equal to 100. And finally, we will say our drop timer is going to be equal to a new timer object, and then this will be, we'll pass into it our drop interval. Now that we've done this, what we want to do is to modify instead of having all the drops move down on screen, we only want the active drops to be updated and displayed because, frankly, we don't care about drops if they're not active and moving yet. So there's no point in updating the position or updating the display information for a drop if it's not actively falling down the screen. Now if I run this, I will see absolutely nothing is happening in regards to the drops because active drops is set at 0. So I is 0. If I is less than 0, update into, oh wait, well, 0 is not less than 0, so this whole thing pretty much doesn't run yet. I mean, if we changed active drops to 1, we would see 1 drop falling, and then that wouldn't help. Now, we need to implement this with the timer because what we want to do is we want to use the timer. Every time the timer is done or has gone through an interval, we want to increase active drops by 1. So we're able to do that. And We can kind of put this in a number of places. So this is where we have the catcher and drops are visual objects happening on screen. So I'm going to update the timer up here. So we'll have our timer management section. So what we want to do is find out if the timer is done. Then we want active drops to increase by 1. So if our drop timer is complete, so we call the complete method for it. If that is true, curly, return twice, close curly up arrow. So if that is true, then we want our active drops to go up by 1. Now if I run my program again, well, a couple of things happen there. Let's watch that. If we watch, boom. And then it crashed. So a couple of things happened on the way to that out of bounds exception error. And what is occurring, and I'm just going to stop it so I don't watch my spinning wheel of doom. So the timer is effectively done right away at the beginning. It's done because if I look in the timer here with it, so because we haven't told it to stop, my elapsed time is going to be greater than the interval, so it's automatically just going to keep returning a true value. The only time the timer doesn't return a true value is when the timer is running. The timer's never been told to start, so we do need to tell the timer to start at some point in our program. And we can do that after we make it. So we're all set to go. Well, we tell the drop timer to start. Now if I run my program, we get a small hesitation, then it crashed again. Okay. Now I'm going to change my drop interval to 5 seconds, now 3 seconds. So we'll see that there is a delay happening here. 1, 2, 3, and now you can see then suddenly they all start falling. We run out of things. Now one thing to keep in mind is if we know that we're running at 60 frames per second, that means it's going to increase active drops by 60 in 1 second. So, and then it will be another 40 within, not even another second. So within less than 2 seconds of running, active drops is maxed out and tanked because active drops is increasing with no limit. But if we look at our code here where it's now cycling through, telling drops to update and display, well, we can't have active drops go up to a finite amount. We really need active drops to max itself out at the maximum number of drops. So then what we can say is if active drops is less than our number of drops, and you may also start to realize this is why we store these numbers in variables, because now if I change my number of drops, I don't have to go through and try and find everywhere that I referenced that as a number in my code. I can just go change the one variable and it changes. And now I'll move active drops into that section. So if active drops is less than the number of drops, then we tell active drops to run. Now when we run it, we'll get the 3-second delay, and then they all start falling. Okay. Better But if we add to that one more thing, where we tell our drop timer to start again, every time we tell the drop timer to start, in essence, we're telling it to start over. Because inside the drop timer, when we tell it to start, we set our start time equal to whatever the current time is. So every time we say start, it's essentially resetting the stopwatch to say, okay, now I'm back to my new 0. It's not like kind of new Coke, which wasn't the same, even though they said it was the same with the new label. It really wasn't. But here we're setting it to our new relative 0 by calling out our start time is now milliseconds. So then when we're checking to find out if it's complete, we're checking based on a new start time, and we grab the whatever the current time value is in the system. Now, I'm going to go back. We'll just go to 300, so it'll be slow, but we'll see. So every third of a second, we'll see a new drop starts falling down. And that's a much better looking version than having all the drops start right away. If you want it to be even slower, we'll go 2/3 of a second so that they emerge much slower on screen. So we have, but you'll notice because of the asteroid wrapping system we have, once a bunch of drops have started, it starts to feel like there are a lot of drops going unless you can manage the ones that you are catching. Adding in the score into our project requires us to track that. So I need a variable that's going to be my score. My score is going to be a whole number, no fractional values in my score, so then I'm using an integer for it. Start out, we'll set score equal to 0. Now, to put this on screen so that we can see it, we have to draw text. This is something new. We haven't looked at it before, but the syntax for doing it is fairly straightforward. One thing to keep in mind is where we do it inside the draw function makes a difference. If we do it early on, say before we draw the catcher and drops, that text will sit underneath those objects. If we do it after, that text will sit on top. So if I want the text to sit on top, I need to then do it generally down near the bottom inside my draw function. So before I figure out how to make my score change, go up, or do anything else, what I do want to do is just figure out how to get text to appear on screen. And to do that, we just simply say text, and we'll be providing an x and y value of where we want it to be on screen, and the text itself that we want to see show up on screen. Now, to do that, as I look at this, the text I want to show up on screen would be score, space. So we put it inside quotation marks for the text itself. And now I'm going to specify value. Actually, and we'll give it, I'll just put a number in so we have it. Now the x value that I'm putting in as part of this will be, I'll just put it to the left corner, but I'm going to put it at the bottom instead of the top because we have all those objects that are kind of clustering near the top, so I'm going to put it down near the bottom. And remembering that this is 600 pixels high, I will just put it at 550 for now. We'll see how that looks. Now when I put this in, let's see what happens into our game. And we can see that the text color is red. But if I don't want my text to be red, I need to provide a fill color for it the same way I provided a fill for everything else. Change the color. I'm just going to use bright yellow. And now when I do it, we can see that that text shows up bright yellow. It's not updating or changing yet, but at least we now have text showing up on screen. Now, currently, the way it's set up is my score will display on screen always at 0. But what I really want to have happen is I want to add to this text, I want to see that variable go with it. And now we can see it still looks the same, but it's actually not using a hard-coded in 0, but instead is displaying the actual score variable in that line. To increase the score, now we can just simply say score plus plus. Now when I run it and start catching the drops, we'll see that the score is indeed going up. Now if you want to see something fun, because the drops are on screen, I can just keep my cursor over a drop and get a high score in the game pretty quickly. So that is problematic. And that is something that we will be addressing as we take this game further.